This is problem number 7 from section 3.4. It says the stopping distance d in feet for a car traveling at x miles per hour on wet level pavement can be estimated by the function d of x equals 1/9 x squared plus 7 over 3x. Remember, d of x stands for the stopping distance. If a driver can see only 300 feet ahead on a curve, find a safe speed limit. So 300 feet on a curve is how far this driver can see. So that's the stopping distance, right? So what we want to use is this 300 and we want to put it in for the stopping distance d. And we want to find out what is the speed limit that makes sense so that that person can stop before they get to anybody that's coming around that curve. So we're going to say 300 equals 1/9 x squared plus 7/3 x. And we want to stop, and actually we should probably write this as an inequality, it would make sense. We want to stop, so this spot right here we would like to be less than or equal to 300 feet. So we need to write this as 300 feet is the largest amount of distance that we should cover while stopping. So we want this part, which is our speed, to be less than or equal to 300 feet. Let's go ahead and write this out. I'm going to actually flip this around here in a second. I'm going to subtract the 300 over. And I'm going to write this as, so 0 greater than or equal to 1/9 x squared plus 7 over 3x minus 300. And then I'm just going to flop all this around. So it says 1/9 x squared plus 7 over 3x minus 300 less than or equal to is facing the 1/9, so it's facing this part of the equation, so less than or equal to 0. Okay, so let's go ahead and solve this then. If we want to solve this, the first step we take when we solve the quadratic inequality is we replace the inequality sign with an equal sign. So we're going to say 1/9 x squared plus 7/3 x minus 300 equal 0. And then we're going to solve this quadratic inequality. In this case, we're going to use the quadratic formula. I mean, it's got fractions in it. It just makes sense. Let's go ahead and use the quadratic formula right away. So we're going to get x equals, and if you wanted to make the quadratic formula easier, we could multiply by a common denominator here and get rid of the 9 and the 3. But I think let's try this out with the fractions. So we end up with negative 7 over 3 plus and minus root 7 over 3 squared minus 4 times a, which is 1/9, times c, which is negative 300. And that's going to be all over 2 times a 9th. Now the reason I left the fractions there is I'm going to use my calculator to do most of the work anyways, so it just makes sense. Let's write it out. Let's use the calculator to do all the grunt work. So using my calculator, we're going to plug in 7/3. So I'm going to use the fraction button and write 7/3, and I'm going to insert these parentheses, so I'm just going to write it just as is. Minus 4 parenthesis, insert another fraction, 1/9 parentheses, negative 300. I should have put a parenthesis there. Enter. I get 1249 over 9. Now I'm going to take the square root of that, and it gives me 11.78. So I'm going to use that 11.78 number, and I'll leave it rounded. So I get negative 7/3 plus and minus 11.78 all over 2/9. So my two options here are x equals a negative 7/3 plus 11.78 over 2/9, and then negative 7/3 minus 11.78 over 2/9. So again, let's let the calculator do the work. So we're going to do negative, bring the fraction in, 7/3 plus, bring back that number, hit enter, and divide it by 2 divided by 9. I get 42.5 mph. Or, let's do this here, negative 7/3. So again, maybe we'll grab this here. And then we can just change this subtraction sign. And we'll divide by 2 divided by 9. And we get negative 63.5. So this doesn't even make any sense. So this part we're just going to ignore completely. Okay, we're going to ignore that completely. So we've got x is 42.5 miles per hour. So it looks to me like, because 42.5 miles per hour is what we got for what we got for a solution for one of our roots, it looks to me like 42.5 would be like a max. I think a safe speed limit then would have to be less than that, right? So maybe 40 miles per hour is a safe speed limit. So I think we could easily say, because we don't want to go any larger than this, we could easily say that 40 miles per hour is a safe speed limit. But you wouldn't want to exceed, but don't exceed 42 miles per hour. Because if you go above 42 miles per hour, let's say you're 43, you're not going to stop in 300 feet. That's the whole point of how we wrote the inequality. So I think that should make some sense.